Hi, I'm Jason Ledbetter, and I want to show you the control system I designed and built for my swimming pool based on the Tiva Launchpad by Texas Instruments. The three goals I had for my project were to make it easier to keep the water clean by providing more circulation to the hot tub, to prevent damage to my equipment from things such as running the pumps dry or freezing temperatures, and finally to make it more convenient to be able to control my equipment from my smartphone. So let's head on over to the pool equipment and I'll show you how it works. I replaced the old box with this new box. You can see that the power inputs come into this PVC in the back here. Then they go through the control system and through this flexible conduit out to the equipment that it's controlling. Inside the box there used to be two mechanical timers. I've replaced that with this Tiva C Launchpad. 5-volt power to the system comes into these breadboard connectors here. This requires moving the power jumper from the default position for ICDI to the breadboard position. This same 5 volts is also used to power the relay coils. The GPIO don't have enough current to drive the relays directly, so I'm using a 2N222 transistor for current gain, and I'm using a diode to suppress the inductive kickback from the inductive load of the relay coil. For analog inputs, I'm using the 3.3 volt reference supply on the board, and I've programmed them for 64 times oversampling, and that's plenty good for this application. The overall flow of the process is signals come in through the input terminal block here. They are processed by the MCU, sent out to GPIO, which drive the relay coils and power the equipment. Regarding communications, this Ethernet connector provides connectivity to my HTTP server running on the Tiva. This allows me to control the system from any smartphone or tablet or computer. Now, instead of running a dedicated Cat5 cable out here, I'm using this power line communication equipment here. So I'm sending the communication signals over my power lines. Alright, let's close this up. Now let's talk about what this can do. This used to be controlled by mechanical timers. Now I can control it from my phone. This is the pressure gauge right here. Here's what the software interface looks like on my phone. My schedule screen allows for creating a schedule of the various pool modes. Once a schedule is saved, it gets stored in the EEPROM so it can be retained when power is lost. As you can see, right now I have the pool scheduled to start at 8 a.m. and run until 10 a.m. The bypass screen provides a way to bypass the schedule modes. You can see right now I have the pump turned off so that we can shoot this video without so much noise. This is very handy for maintenance. So to turn the pump back on into schedule mode, I just remove the bypass and the pump turns on. As soon as the bypass is removed, the system resumes the schedule automatically. Now let's take a look at the valves. You can see I've installed an actuator on top of the supply valve. This lets me control the position between pool and spa. There's not a lot of clearance here. When they installed this, they didn't leave enough clearance for me to put an actuator valve, so it looks like I'm going to have a little plumbing work to do later. So come on over here and let me show you how the actuator works. It's 10:24 right now, so we're in spa mode. I'll put the actuator in bypass and change it to pool mode, and the actuator will start to move when I hit done. The valve position in spa mode, let's turn on the heater and heat up the hot tub. Here's the heater right here. So for water and temperature sensors, I'm using the TMP36 temperature sensor. The air temperature sensor is installed, but I haven't had time to install the water sensor yet before the video deadline, so I'm temporarily using the heater's controls for the heat set point. But I can turn on the water with my the heater with my phone, and that's already a big improvement. To sense pressure, I'm using this pressure transducer. This installs directly where this pressure gauge is installed now. Unfortunately, I didn't get time to do this before the deadline, so this is going to have to go on the to-do list too. Well, that about covers it. So now that you know how it works, let's walk over and take a look at the pool in action. So overall, I'm really happy with how this turned out. I've got a few little things left to do, but it's already way better than it was before. If you're interested, the bill of material cost me about $600, and for what it's worth, my pool guy says he would install a comparable system for $3,500.
Daddy, turn on the bubbles!
You ready for some bubbles? All right. Thanks for joining us.